Okay, I mounted this stator plate, which is version number 1 of the double coils and double cores, and one coils wound left hand rule, the other one's right hand rule, so I have opposite wound coils, and I have it between two discs now with 8 magnets. And my first test is going to be the magnets straight across from each other. Here's a magnet here, a magnet here. And here's the amperage going in AC amps coming from the grid, which is right there. And here's my voltage. All these coils here, there's 8 of them. Here's one. Here's another. They're all in series. I have 8 coils in series, and it's coming out these 2 brown wires, and it's going to the meter. And 4 UF run cap. And the rotors aren't, it's kind of quick and dirty here. I could work with the rotors and get them a little tighter. They're pretty good for this first test. So just telling you what's going to happen now, because after I start it up, it's going to be like noisy. So when I have the magnet straight across, and remember the north is facing in, the north is facing in, so it's like banging both sides of the coil and core at the same time. And it's going to be drawing about 100 milliamps and 120 volts, and I'll be making about 450 milliamps, but I won't be making very much voltage, probably only about 4.2 volts. And what I can do is put a full wave bridge rectifier across it, the AC legs across it, and pump DC into a cap, like a 2 UF cap, and now I can get the voltage up to 9 volts. But to me that's kind of cheating, and as far as Lenz's law goes, when I short it out, it'll go up. It'll either not go up at all, or it'll go up about 10 milliamps when I short out the coils with either an ammeter or just short them out. So that's not so spectacular, but you know, there's only how many? 25 gauge wire, and there's only 48 feet of it on each coil, and 48 feet back here, so you can't expect to make much voltage. But this is the first test, so now I'm gonna stop this test, and then I'm gonna make these magnets so they're that triangular pattern with one magnet here, and then in the back side a magnet here and a magnet here, and that's supposed to make AC. And I'm going to be testing in AC each way because DC shows nothing. And here goes. Okay, so I'm going to pause and then start it up. Okay, it's running now. Here's the draw in amperage AC from the grid. say it's 0.95, but let's say it's 100 milliamps. The voltage in AC I'm making right here from the two leads is only 5.7 volts AC. Now I'm going to short it out. Amps AC, that's pretty good. 500 milliamps of current, but the draw has gone up. Okay, I'm going to hook it up full-wave bridge and put it in a cap and see what I get for voltage now. Hold on 1 minute. Okay, I have the full-wave bridge rectifier, AC legs across the output, DC into this 2UF cap, and it's about the same current. So let's look at voltage. Here's the voltage. It's about the same. This is with the magnet straight across. Then I'm going to short out the line, and it goes up to 0.12. If any of you have been watching my videos, if I stagger these rotors a little bit, I can make it so it doesn't go up. But right now I have it straight across. Okay, I'm going to put it on pause, and I'm going to move the rotors. So there'll be 2 here and 1 here, that thing. Okay, 1 minute. Okay, so now the magnets are, this is the plan, is to have magnet here, and then 1 here and 1 here. I've talked about this 100 times. So this is 2 magnets back here like this, 1 magnet right in the middle. So I guess this would be 180 degrees off with the magnets whipping. First this side of the coil gets hit, and then this side of the coil gets hit. And remember, the magnets are facing in with their polarity. So north in. And now we'll test it like this, and I'm pretty sure what we're going to get is less amperage, about 350 milliamps, and about the same voltage. However, I can knock the voltage up to about 9 volts with the full-wave bridge rectifier. So that's what I'm expecting. So I have it in voltage right now in AC 60 volts. And here's the amps in. I'll put it on pause and start it up. Okay, it's going 1800 RPM. 100 milliamps. It's on voltage, it's making 447 volts. I mean 4.47 volts. This is in AC. So that's what it makes in AC. You can see the coils. There's 8 coils back there. There's 8 magnets. So now I'm going to do the short test. Put the meter in 20 amps. Short it out. Now we get 360 milliamps of current. The draw doesn't go up as much, but it goes up a little bit. 10 milliamps. So that's what I get like that. Now, whoa, look at that. Now I'm going to hook up the full wave bridge into this 2 UF cap. It's in AC now. It doesn't make any difference the current coming out for that. You know, I could also try a cap in series, but I don't think I'll do that now. Okay, so let's look at the voltage in this capacitor now. It's in DC now because it's been rectified. The meter's in DC. So I'm getting 10 volts out of it, better. So I'm kind of cheating by rectifying and putting in a cap, but you know. So there's the very first test of this. I would say I need a lot more winds in these coils. A lot more. Because the voltage is not too good. This will be my next test. I'll throw this in there. And this will have normal coils with black sand cores. I expect about triple the voltage, but I don't really know what's going to happen. Okay, well, don't know what to make of it. Wasn't super outstanding anything. Still very low length, but it's not making much power though. Okay. Thanks for watching.